So here from the lab, work under Eddie Barker and Hank Kafka in the Access Technologies organization. So it has graciously agreed to come here and take us through some of the information. There's been a lot of pronouncements on this technology recently, so it'll be good to get a briefing on it. A couple reminders before we start the call. Number one, all of your mics are muted, locked. If you'd like to ask a question, please send me a private chat note just to me, and I'll cue that up for Ed. You can try the raise hand function as well, in which case make sure your audio and your web are linked together. And finally, if you would like to follow along with the slides, they've already been posted up on TechSpot. So with that, let me introduce Ed Walter. It's all yours, Ed.
Thank you, sir. All right, so as was mentioned, I'm Edward Walter. I work in, actually the labs is the known term. I guess we're called Technology Design and Architecture. Been working on this Access specific technology since probably around 2005 when we first started kicking off the Lightspeed project as a whole. So we've had, the reason for the conversation today is really around activities that really started to spin up. We've been doing PON since A-PON, and then B-PON rolled out, and then started doing G-PON. But we really felt the desire to push this harder around 2013. So when we had, then that was a direct result to some competitive pressures in the market. So and that came out with a gig, 1 by 1 gig service offer. So with that history on that, that's kind of why you see so much more activity in PON today than we did in the past. I mean, we had a lot of people working on it in the past, but really never gained the traction from a deployment standpoint. Historically, we deployed before pre-2013, we deployed most of the stuff was greenfield. We'd go into areas, new subdivisions, and they had to actually even meet a certain criteria, so it wasn't even all greenfield. And then we'd investigate or leverage the PON technology that we're going to use. And I'm going to talk about the vendor in particular throughout the deck. And then after 2013, it became more of a greenfield overbuild, specifically tied to the $12.5 million commit to the FCC. So it became more of a brownfield overbuild solution as well, which was new for us. But I'll talk more about some of the stuff in the deck here. So that was just giving a little historical context. We've got, I guess I'll walk through this slowly. I've got, there's two avenues right now kind of going on in PON. There's always the development or design standardization around new optical improvements to get better broadband speed. So today we do GPON, it's 2.5 gig. In the future, we want to evolve to 10 gig, 25, 50, 100, whatever the next flavor we decide to implement. And then there's the other thing. I think everybody understands it, that throughout the company there's been a push for SDN and network function virtualization. So you'll see down below, you'll see an SDN and VNFs. That's just a function that would have traditionally been found on a box. They want to move it to software-defined platform. So we're going to talk a little bit about that in one of the sections of the training as well. So you'll see those two factors playing out in anything development-wise that happens moving forward. There's always a time to market issue, so often you have to account for that when you make decisions around your medium time frame architectures. So we'll talk a little bit about that as well. So let me go ahead and jump to the next slide. So some of the kind of the objectives we have from labs and working with our partners over in planning when we start working on the next or the evolution. So everybody saw, I'm sure if you didn't, you can Google XGS press releases for AT&T. You'll see that we've had a couple out in the trade magazines lately. I actually speak on it usually when I go to Broadband World Forum or OFC. So we've gotten the word out that we are definitely planning to move to XGS PON. Right now, like I said, we do 2.5 gig / 1.25 gig GPON. We're moving to a 10 by 10 gig PON. The goal was part of this wasn't about technology. It was about getting technology at a price point that would make it attractive for us to deploy. So we've successfully done that. So you'll see through these things here our tenets or our goals as we design PONs or try to move to the next PON, right? And since 99% of what I talk about for PONs is consumer based, and even the HISA that we sell to business looks very similar to the consumer-based solution. So no, we don't currently today put any SLA-based traffic on our PON. The ACE over PON stuff, none of that is currently being planned or planned to be developed. So when I talk about PONs, I mainly talk about best effort. But you'll see some of the things we're doing here. We got SDN NFV. That's always a tenet. We work in part of our job is D2. So when we look at this, we've got a lot of activities going on in that. We'll talk about this in this deck about the activities we're doing in the D2 space. We also tend to look across the board. Part of the work I do in standards and my counterpart, Kent McCammon, do is we spend a lot of time at the ITU-T standards bodies as well as the IEEE. And part of that is to, while we dictate or try to drive requirements, we also canvas the requirements from other operators with the goal in mind of trying to line up on where the volumes of optics go. Because, in PON, the one big killer for cost is your optics cost. So that tends to be a driver for us. So you understand kind of where XGS came from. We lined up where we knew the largest user optics is, and that's China. China tends to drive hundreds of millions of optics. And so if we line up on those where it makes sense, then we tend to get we enjoy the cost benefit of picking those volumes. Automation, this is Indigo D3, looking at ways to, probably doesn't affect the customer per se, but it definitely would be useful if every time I went through a tech dev development effort, I didn't pay and start from square zero again. So we try to find ways to automate. This is something that we're currently looking at for D3, like I said, with Indigo. Edge compute. This one is relatively new, mainly because we are looking at ultra-low latency applications. I've got several meetings planned and places to go to look at wireless support over PON. This is a relatively new topic, so I don't really have a lot of information on that other than this is going to be extremely low latency beyond what we currently do today with consumer. But it is something that I'll kind of briefly discuss just so you can understand where Labs is going on the PON front.
Hey, Ed, could you just clarify, is Edge Compute, AT&T Edge Compute, is that the new name for AIC? Or is it an overlay to AIC?
No, so let's just keep it. So AICs tend to be the data centers at certain points in our network, call them at certain COs. They're not everywhere. AIC did propose an edge compute option. That doesn't mean that will be the edge compute option. There's also other ones out there called AEC and some other ones right now I'm not allowed to talk about. So let's just say there is going to be an edge compute design somewhere being driven by a service application requirement. And our goal is to be able to leverage that. I don't know that we're not going to be funding the development of edge compute within the PON platform, right? We're going to do the PON, the access, but because of latency sensitivities like 5G with a certain optional split, if you're following any of those standards, there are, microsecond latency requirements, which are very tight and that's just round trip, not the service. But it is significant latency requirements that will force stuff to be pushed out to the edge. And if you've listened to the president of Labs, Andre Fuge, ever talk about this, he's big on this as well, right? I think we all see that latency is going to drive things to the edge, and our network tends to be perfectly positioned for that. With over 5,000 COs, we tend to have that. And of course, getting the cost down per installation is the biggest problem right now. But the goal is to support low latency applications with some kind of an edge compute service, and whatever that may be, because that's a little bit in flux right now, depending on which way we end up going there.
Okay, very helpful. Thank you.
Yeah, and then the open vendor interoperability is always kind of nirvana for us. In the PON space, people throw around 988 standards saying, okay, we've got interop between ONT and OLT, but the problem we run into often there is it's just the interpretation of the vendor. OMCI is written in a very, and for those that know, OMCI is the communication channel between the OLT and the ONT. You actually always talk to the OLT, and the OLT talks to the ONT from a management perspective. That OMCI does everything. There's MEs in it that are entities, managed entities that will communicate between the two devices. So it tends to be a bookend solution. And some vendors have been or some operators have been more successful than others at implementing various mixes of ONUs in the standards that come ONUs, ONTs with OLTs. But in the case of AT&T, we've always just had one vendor in that space. But that doesn't mean that we don't have a requirement for open interoperability. And in fact, we've actually published an open OMCI spec that we're going to start using with any vendor that we work with, and I'll talk about that when I get to the D2 stuff. The last piece is really around PON convergence, and this is because I mentioned earlier that I actually attend the IEEE 802.3 CA task force or task group. It's a PON group under the IEEE that is currently focused on 25 gig, 50 gig, and 100 gig PONs. For most of us, we look at it and go, where am I ever going to use a 100 gig PON for consumer? But this isn't necessarily about consumer play, although some people are looking at it that way. Our interest from AT&T is really about, is there a place with a 50 gig or 100 gig PON supporting a 5G backhaul or some kind of a 5G design solution? But more to come on that. That's still ways out from a standardization completion effort. We're probably still 2 years away. On the ITU-T side, there's a lot of activity as well. That's through what they call Standards Group 15 Question 2. And that group does pretty much all the PONs we deploy at AT&T. All our PONs are really based on ITU-T designs. We don't really use IEEE. That tends to be a cable MSO design that's used with DOCSIS. We tend to use, also using DPoE. We tend to use IEEE or ITU-T. Most of the telcos use ITU-T, and that's kind of why we attend those and support those through our activities as well. But they're also just now starting to look at what's the next step after 10 gig PON. They've got two in the plate right now. One is NG-PON2 with multiple wavelengths. And then you've got another one called XGS, which we're employing or going to be deploying. And that is really using a hybrid approach, which was kind of using the IEEE PR30 optics that are single wavelength 10 gig and buckling them onto the NG-PON2 MAC. So it was kind of our first attempt at a hybrid approach. It went through the standards, got ratified last year, and we're actually developing it right now at AT&T to deploy sometime in late 2018. But what this really drives is when they say PON convergence is you've got two standards groups building PONs, and the vendors in particular really would like to see some convergence of the designs. They don't get rid of standards organizations, so the standards groups don't go away, but some agreement between the standards groups to land on specifications that are the same. And this sounds relatively simple. For most folks, you would say, yeah, that's an obvious thing, but in some ways, this is like two rival high schools trying to get them to talk to each other. Both groups have a lot of smart PhD guys working on the stuff. Both think they're smarter than the other guy. So this is an activity that AT&T is pushing hard. I'm actually the liaison rapporteur between these two groups trying to get them to play nice. So more to come on that, and the hope is with 25 or 50 or 100 gig that when the IEEE pushes theirs out, the ITU pushes out something that's very similar to it. So you don't end up having two widely different solutions. And this is probably going to really just be at the optical, physical layer and the MAC layer. I doubt we will probably converge on management, although there is talk about doing that with NetConf Yang through the broadband forum, BBF, at some future date. So let me, I just kind of talked a lot to this, but just so you can visually see it. On the standards, you've got both the IEEE efforts, like I mentioned. Right now, they had finished up the EPON in 2004. 2009, they did a 10 gig PON EPON, which was a 10 by 1, and then they're now working this between the 10 gig EPON and the 100 gig EPON. This is that mention of the group, the 8023 CA group that meets every 2 months to continue to evolve the standards for this higher level support. just note the 100 gig PON is pretty hard to do technically right now. I mean, with enough money, you could probably do anything, but the reality is the problem to get to 100 gig is it's just exorbitant. So this may take longer. That may be the hardest piece to solve in the equation. The 25 and 50 gig should be relatively straightforward, but the 100 is going to be almost impossible with the technology today. So up above, you have FSAN. This is a full-service access network. This is a group of operators that have been meeting for a very long time to discuss requirements. ITU-T, we usually feed those operator requirements into ITU-T. As you can guess, we are a board member on FSAN. We meet with the likes of Verizon, British Telecom, Malaysiacom, Orange in Paris. It's all the big operators. They tend to attend FSAN, drive the operator requirements into the ITU-T, and that's where these requirements, these technical designs come out from ITU-T based on the operator requirements. So as you see, we tend to like this approach because it takes into account the operator requirements when we develop solutions. The FOAS, or Future Optical Access System, you see far to the right, we've started pushing this around. Now we actually partnered up last meeting with the ITU-T and proposed with a vendor work on a 25 gig PON, mainly because of the work going on IEEE. Right now that's generated a lot of conversation, so whether it's 25 or 50 or something else, that is kicked off now, and I assume that would be the Future Optical Access System. I also assume it will be before 2021, since we're trying to use it for 5G backhaul. So I probably won't spend a lot more time on this, other than if people have questions, I'm more than willing to send you additional information on the standards. But it's a big part of our life over here. So I apologize now if I'm going to make this simplistic and people are going to get bored, but I'll try to get people grounded on the pieces we have here. So if you look at in the standards, there's really three components to the PON. One is on the left-hand side, you'll have some kind of active electronics and OLT. In the middle, there's something called an ODN, or an optical distribution network. In this case, I show a coexistence element and a splitter, but it's the fiber, it's everything. It goes from the frame in the CO, where the fiber would start right off the PON port of the 7342 or 7360, and it would cross miles of fiber, splitters, and then it would eventually terminate on an NTE device on the outside of the customer home. From there, the third element is this ONU device. It can either go inside the house, as we do today with GPON and the ONOs from Nokia, or we can go on the outside of the house and deploy 240, or even go back a little farther to 210s that we've got deployed. But it would go on the outside of the house, and that's kind of your major components of a PON. And whether it's XGS, single wavelength, or it's GPON, or it'd be a future single wavelength 25 gig, the overall design pieces don't change. You still have something on the left that's active, you have something on the right that's active, and in the middle you got a passive ODN network. So what I show here is really kind of, and I probably should have put some more introductions on the XGS, but I thought it was relatively straightforward. Didn't put a lot of extra information in, and I was planning to really just talk to it. So what I've got here is we don't deploy coexistence elements today. So what you would see is a GPON OLT, and it would have a straight line basically to a splitter, and you'd have a 1x32 split, and it would feed nothing but GPON ONUs. And I use 1x32 because that's our design criteria, but it depends on the reach. So as I get farther away from the OLT and the ONU, between the OLT and ONU, I use split reductions to gain additional optical budget. So everything is done based on optical budget. As I start to lose optical budget, the farther I get out, what I will do is I will eventually lose receive sensitivity on the ONUs and the OLTs, and the signal will drop, and I won't be able to make connection. So what we do is we throw a splitter in there, like a 1x16 at a certain distance, and that PON would then be 1x16 driven to give us additional reach. And then when I find that I can't engineer to 1x16s, I go to a 1x8. And after that, then I say, well, I guess I'm going to put a shelf in. So at some point, I will actually make a decision, or I won't. The construction engineering guys will make a decision on placing a remote OLT. And we'll talk about that too. I actually have a picture of an FX8. It's a 7360 shelf. So we'll talk about that briefly. But what we're trying to move towards is using a coexistence element, which is just a passive, basically, splitter device, reverse splitter, like a diplexer. That I show two elements here. It could be more. And then what you do is you have inputs into the coexistence element, and you have a single output to the splitter. Now, you say, well, how does that work? Well, what we have is you have down below, you see the spectrums. So I only show the upstream, but there's an upstream and there's a downstream, but just to make it fit on the slide, I just showed you the upstream. So there's actually two wavelengths, all right? So for GPON, you'll have this 1310 nanometer center wavelength, and it's 40 nanometers wide. So they have some narrow, but what I'm showing here is the reduced, which is what we deploy in our network. There is, in the standards, you have something just called, just a wide upstream, which is 100 nanometers. That was very early in the process. Nobody really ever deployed it. And then you had the 40, which we deployed exclusively or heavily. Most of us do, most carriers. And then you have what they call a narrow GPON, which is from 1300 to 1320. Not a lot of people have deployed that. So what I'm showing here is kind of what we deploy, which will be 40 nanometers wide. And then when you look at the XGS, this was important because we really wanted to use a coexistence element to grow. Hang on a second. Okay. So we may want to use the same fiber, and I'll kind of talk a little bit about why. And then we can just place the XGS stream of 10 by 10 gig on the same splitter by using this coexistence element. It kind of merges the two wavelengths together, and then I put it down the same fiber, and then it comes out the splitter and gives me the ability to change out ONUs when a customer orders service. So why do we do this? So I'll give you a little history. So when we went from BPON to GPON, BPON was the initial, after APON. I'm not going to count APON. So BPON, we deployed a significant amount of BPON. And then when we decided to go to GPON in the 2005-2006 timeframe, with our first 7342 shell from Nokia, we didn't have a way to migrate because the wavelengths stepped on each other. So what ended up happening is we had to go out in every case and put new splitters in with new PONs, and PFPs started getting filled up to the point where you had to do grooming and everything to support the additional customers, even if you were swinging them. So it was a mess because you didn't have any flexibility to collapse down your customer base. Well, with this coexistence element, it gives you the ability to run the next technology as long as you've got wavelength multiplexing going on where you're not doing some kind of time division. You can actually just slap in the next ONU at the next service requirement or request, and you can migrate to the next technology without having to mess around with, putting in a new splitter. I'm going to caveat, this is not there today, right? This is a design concept that we're pushing to get funded. It isn't quite in a development stage, but this is a target architecture for us. Use the CE to allow us to migrate to the next technology. And when I talk about 25 gig, I'll reference this again, to allow us to do graceful migrations at the PFPs without having to go in and groom them, or heaven forbid, have to do something more significant to the PFP. So this is our plan for the future, and most as I just talked to you around the wording on the slides. So, yeah, like I said, if you've got any questions on this, I can definitely talk offline to you more about it. So I'm going to go through this. My build thing worked really badly, so I'm going to talk about this a little differently. So like I just talked about, GPON 2.5 by 1.24/1.25 gig. We actually deployed 1 gig services on this today. And you're probably going, well, how do you do that? Well, it's not really 1 gig. It's probably closer to 960 because of the overhead. And, it's a 1 gig Ethernet interface. But it's best effort, and it's a shared PON that really, at the end of the day, we're not guaranteeing 1 gig traffic. If this was SLA-based services, we'd have to do a completely different design. This is HISA. So this is how we deploy today. It's with a 7342. Let me put this on mute so it doesn't keep beeping. It's based for HISA. We have video from IPTV, but it's designed to support customers, a large number of 1 gig services on this single link. So we're doing that today. We have a significant deployment of this with 7342s and 60s from Nokia. As we do this, builds out. There's your 32 customers. Now we go to XGS. XGS is the 10 by 10. There is an option to do 10 by 2.5, but we pushed directly to 10 by 10. We felt we could get the volumes to get the price down. We did. So we're not even looking at a 10.2.5. The way that we make this business case work is we put it on 64-way splits. So right now the plan is for customers we can reach with the optical power budget, we're going to go do 1 by 64. So that means I can save a few dollars on the F1 plant because I'm now doubling up on my F1. I get also, and because the cost of the technology is still a little higher in the OLT, so the way we offset the cost is we offset it by the cost of the F1 plant. As you can see, it's 4 times greater in the downstream and 8 times greater in the upstream. It's our first really attempt at symmetrical PON. And so like I said, we're developing this. The last I heard was it's somewhere in the late 2018 timeframe is when we're lining up to push down the field. What else? And the big driver is multi-gig support. So right now today we offer 1 gig. As we look at with product, we're looking at 2 gig and higher. It's not really necessary that there's this suddenly something out in the network for consumer that's needed, but it is it's more to remain competitive when others in the industry specifically on the cable side push out multi-gig offers. That the technology is there to support it. We're not actually driving the multi-gig project. That's being driven out of product. And I apologize. I don't have an actual accurate timing on when they're planning to push that out. It will be after the technology gets developed, but it will follow this. Right now, what we're focused on the development side is to get the XGS solution built, and it will offer it initially with the same services we do today. But as product develops the next generation of product tiers, they can then use this technology for a multi-gig offer. Now, since I talked briefly about the 60s, or I've mentioned it as well, you won't see anything about the 42. The 42 is out there. We have thousands of shells that are 42s, 7342s that is. But they are we're only slotting cards. We don't put new shells out there. If they need a card for capacity, we put a card in. Right now, the workhorse since about mid last year, somewhere last, I thought maybe it was 2015. It's been a while. So we've been putting 60s out there at a very fast pace to support the 12.5 million build. So I think we've actually got more 60s than 42s now. So I'm going to talk about the 60 because that is a currently being deployed shelf. And will actually be deployed with the XGS as well. So as you can see here, we've got how this works. I wouldn't say this is absolutely 100% of the time accurate, but for the most part, the FX16 will go in the CO. So we always place an FX16 in a CO, and we use the FX8s only in cases where I need to put a remote. They have an FX4, but we didn't develop it. Mainly because these two shelves, the only difference is the shelf density. The actual cards are identical, so I can use a line card in either shelf. I don't have to buy another set. So whether it's an FGLT-A or B, which are the GPON line cards, they go into either the FX16 or the 8. If I want to use the FWLT-B, which is the 8-port XGS card, it goes into either the FX16 or the 8. I don't have to have another set of cards that are unique for the remote system. The same common system cards are used. Everything is the same. Literally the only difference is the size of the shelf or the density. So as you can guess, FX16 means I've got 16 line cards. There are actually more slots, but 16 of those slots are used for line card support. And as you can see, there's 8 on the left and 8 on the right in the middle of the commons. In the FX8, it's 8 line cards. No big surprise there. I don't think there's anything else here that's of importance. Yeah, so I already mentioned, like I said, if you want to know if it's a GPON, if you see an FGLT-A or B nomenclature, that's a GPON line card. A's are end of life. That's why you see the B. We're getting ready to deploy the B, I think, at the end of the year. No major differences for what we're using it for. I would say technically there is there is the ability to support super jumbo frames on the B, but since I don't have a business service that requires that, we're not developing it right now. On the FWLT-B card, really the only big difference is it's XGS and it's only 8 ports. That's the max. They add an A card that we actually use in labs testing, but it will not be deployed in the field. So what you would see is if you see an FWLT-B nomenclature, that is your 8-port XGS card. These can coexist together in the same shelf. So you'll just, of course, use different slots. But the last I heard is potentially if you're ever looking at one of these shelves, I think we discussed, I don't know if it became final, is that we would put, we start GPON cards from the left to the right, and then we would start the XGS cards from the right to the left. So you potentially, if they implement it that way, there should be you should be able to view it easily. We don't put any, the GPON cards are only 16s. We don't use any of the 8-port GPONs. So the other way to look at it is if you see an 8-port card in a line card slot, that's going to be an XGS card because we only put 16s in for GPON. Okay. Okay, so we won't spend a lot of time on this, but I thought it'd be interesting just to talk about when we say full PON throughput. So we've always had, when we do PON designs, we've always kind of tried to design to the tenet of full PON throughput, which means when I come into the shelf, the number of inputs coming in on the PONs would equal all the way through to traces to the NT card. It doesn't mean that I have, add up all my PON ports and I put that amount of northbound interface to the 7450. That's definitely not going to happen. But it does mean that through the shelf itself, I should be able to push my full throughput through the shelf. That way I'm not worried about capacity bottlenecks happening in the shelf and I'm not hearing about it or seeing it. So what we do here is we look at the amount of PON, and as long as I can add it up and feel realistically confident about it, then I'm usually good to go. Now, there's an exception for the XGS stuff. So as you can see here, we always deploy in a CO shelf, we always deploy 2 NT cards. There was an initial thought maybe I'd deploy both and not fiber at both, but we actually now, all 60s go out with 2 NT cards, and they each have a 10 gig interface on. So we do 20 gig lagged. So you'll have a 10 gig on NTA and you have a 10 gig on NTB, and you will lag that to start out with 20 gig. I don't need 20 gig capacity to support my customers, especially day one, at least right now, even with XGS, because of the best effort, and it's just bursty in nature, so you don't have sustained long bandwidth usages. So mostly the reason we put 20 gig in is to have equipment protection. So if I have an NTA card go out, the NTB card would immediately pick it up and would keep trunking, would keep going with the other 10 gig. It's not really about I need 20 gig of capacity to support my customers. It just happens to be that we have resiliency requirements that we needed to meet between the 7450 and the FX16. And I guess I should talk briefly about that, right? Our aggregation switch that we tie to in Lightspeed is a 7450. It's a Nokia large switch/router that can support 1 and 10 gig interfaces. We now use it pretty much exclusively for PON with 10 gig interfaces. And then from there, of course, from the 7450, I don't have the picture here, but it routes and connects it up into the HISA network or the VHOs today, eventually without, in the future, no VHOs, but basically gets us to the internet for HISA. Like I mentioned before, you got LT cards on the left, LT cards on the right, and then in the middle there's a thing called an NTIO. Don't get too worked on that. You won't. I wouldn't say never, but you won't see that in any shelves we have. That's just a network card that has a bunch of more interfaces on it. So if I decide I want 100 gig or another 8, 10 gigs, I could develop this card and slot it in the shelves, but we don't have any pressure for a need like that. So the focus is really right now on the NTA and Bs outward. And as you see the bandwidth, you start adding up. Like I mentioned, you start adding the bandwidth up between the traces, and that's kind of gives you an idea of the calculations we run through when we decide what NT cards to use. All right. Now, this was something I gathered on some product offers for both our FTTP and GFast. I didn't talk a lot about GFast, but I guess I should maybe define that a little bit here. So with FTTP, we've got a 50 gig offer, we got a 100 gig offer, and then we got this 1 gig by 1 gig offer. They don't offer the 500 by 100. That's only offered down on GFast. GFast is a fiber-fed distribution point unit, or DPU, and it can offer up services across twisted pair, unshielded twisted pair in particular, and coax. So when we merged with DirecTV, the coax thing came to front and center on this. So we originally were developing GFast as a twisted pair, and originally the standard was a twisted pair technology. It means you'd come into the DPU with fiber. It would then it would pass it out via enhanced vectoring protocols with this GFast technology. That actually is basically, it's not magic. It's from 0 to 106 megahertz, so it gives you this wide spectrum, and it gives you significantly higher speeds, as you can see here. With the DirecTV merger, it was decided that we got access to coax in these MDUs, and we should probably be trying to use that as well, and it makes a lot of sense when I'm doing DirecTV dish installs. So we pivoted the technology. The access team worked with the standards, and we actually created a supplement to the GFast standards that included coax support as well. So when you see GFast right now in this first phase, it's a twisted pair and a coax technology that can support up to services up to 500 by 100. It's only for MDUs. We do not deploy GFast as a fiber to the curb technology per se. We only deploy it when there's MDUs out there that don't want the fiber, or it's too disruptive, and they don't take the fiber to the prem. Then we'll go on with GFast. So it gives us a really good competitive mix for speeds that complement the FTTP build, because GFast right now, while we do some stuff out of region that's doing point-to-points, GFast as a whole is designed to sit right on top of the PON network. So I could put an SFP ONT inside the GFast unit, and it would just be supported off the end of a OLT as if it was just another ONT. In this case, it's really more of an MDU ONT. We offer video, as is mentioned here, IPTV. I guess the question nowadays you run into is what video. So we do IPTV still today. We're not pushing it hard, but it's out there. It does still require VHOs, and then we have DirecTV Now, and then there's future services I'm not really going to talk about that are coming. That that it's really influencing how we design our future access networks. But for now, we are still designing everything to support multicast traffic from IPTV and on all the unicast flavors. Voice is TDM voice via copper. For FTTP, this is a little unique. This is back in the DSL days. It was just a passive connection, or you had at the actual cross connect, you could actually connect in the copper coming from the CO that had TDM voice, and you had just went passive, and it was layered on as a frequency on the same copper cable. In fiber, this is a little different. You can't do that. So with fiber, we put something in the CO called the GenBand G6. It talks to the classifier switch. It converts TDM voice into an IP/layer 2 VLAN type solution, and it pushes it across the fiber along with the data traffic. And then remember I mentioned outside house type stuff, placing ONTs on the outside of the house. The reason we do that is regulations, requirements from the FCC. So we actually place a 240, in this case the newest one is the 240 ONT in a clamshell. It has two TDM voice or analog voice ports on it. And so what will happen is that G6 will transmit across the 7450 down through the OLT, come out to the ONT. The ONT then takes that and converts it back to analog, and then it plugs into a home wire just like you do today with a copper solution. That's really the only difference. When I have another option, it's called VoIP, and of course, and we push that through the residential gateway. So there's analog ports on the RG, whether it's the 5268 or anything like the new BTW. Those all have analog ports, but they only talk VoIP. They don't talk to my G6. So if just from the numbers I've seen, a majority of the traffic now we sell for voice actually is terminated at the RG. We have a small number that actually end up with TDM voice, and it's not really because the customer orders it. It's normally because they might only order voice. and we don't really have a naked voice offer on top of broadband. So what will end up happening is that they get a 240 placed on the outside of the house, they get their POTS service, and that's it. But it does require G6. Okay, what else? Okay, so this will be good to refresh some of the stuff we talked about. So remember I mentioned the central office today. We have a 7450. That's my switch aggregation device. I might have multiple 7360 sitting there that tie back to the 7450. And then today we deploy an 010, which is a GPON device only, and that's data only, and some kind of like a gateway like the 5268. The other option is if I put it on the outside of the house, I use the 240, which has a couple of analog ports on it for POTS, and then I have the same thing. I still use a 5268. In both cases, it's a two-box solution at a minimum. For the future PON work, and which is really near future, we have the 7450, and then we've got conversation around D2. And what the D2 is there's a lot of work going on around, it was just mentioned earlier, Bill had mentioned AICs and fabrics. So in the D2 world, when you see D2, it really means some kind of a fabric solution, not necessarily a big gigantic iron box. So that would mean I would connect to some kind of a switch in the CO. They call it a leaf. It's a switch, right? So you have different types of leafs, but there's 24, 48 port switches. They're 10 gig in capability. Doubtful I'll have 100 gig interconnections, but they do have switches with 100 gigs on them. So what you do is you plug in either a 7360, and these are not required. So I can do D2 fabric without using D2 box. I can do D2 fabric with a 7360, or I can do vice versa. So the way we've designed this. So on the left-hand side, you eventually run into more D2 fabrics. Right now, it's all 7450s, but eventually, maybe over time, the fabrics show up. That's good. To me, it's just an interface. So on the right, in the middle there, rather, it's the 7360, and we are right now talking in phase 3. We're testing vendors right now in phase 3 for the software-defined network function virtualization box. I'll talk a little bit more about this. I can't really talk about the vendors because it's not public knowledge, but I can talk about the technology. And then on the right-hand side, the other area we focused on for 10 gig PON was really working with the AEG group on their desire to drive towards a unified box. They call it a BTW. It has the PON MAC chip built into the RG box. So you end up having you'll have a fiber plate basically on a wall, and then they will ship an RG, or they'll bring an RG, and that RG will have the ONT integrated inside it. And this was a really big win for us at AT&T from a cost perspective. It's going to take some work to work through all the details, but the plan is this was a significant cost reducer. And I think for folks to understand, right, for us, the biggest impact reducer, I guess, is as I move from left to right, from network at the core to the customer, the more money I save at the customer edge is it's direct versus some of these other costs are more shared. So they don't seem to make as big of impact as saving money at the customer edge. In this case, this was a significant cost saver, so it made a lot of sense. The 250 I mentioned is really just the big brother to the 240. It does XGS. For anybody that tries to read the nomenclature for Nokia, the first digit means the number of POTS lines, the second digit means the number of Ethernet, and the third digit means the number of RF ports. Well, since we're not Verizon, we don't do RF video, so that's always going to be 0. And in this case, the Ethernet is 5, and that means there's one 10 gig Ethernet interface in this box and 4 ones. And then the 2 is the number of POTS lines or TDM voice lines. So, for example, the O&O, it's got one data port on it only. That's it. There's no POTS. There's no RF. For the 240, there's two POTS lines and there's 4 Ethernet. Those are all 1 gigs because of the chipset. But that's just for information. If you're ever looking at a nomenclature from Nokia, you can kind of figure out what they're trying to sell you. All right, so I'm not going to spend a lot of time on this. I think we'll talk briefly about it, but today we push a lot of Cat 5. The future would be Cat 6 or fiber. Our preference is to push the ONTs into the home and try to get completely out of the POTS side of this, but that there's still instances where we do that. So you'll see, and the reason for that is because in the O&O case, it's a non-hardened device because it's inside, so there's significant savings there as well. And it also meets our requirements for the BGW. And like I mentioned on the BGW, the one footnote is the fiber-to-fiber jack inside and a jumper from to the BGW from that fiber jack. That is probably going to be the biggest pain point for installations in the home. So take a break for a second, and then we'll talk about software-defined network function virtualization, XGS PON. Let me see here. Let me catch up with everybody. Let everybody catch up a second here. Okay, so we got time still. It's 11:18. All right. So I'm going to give you a real high-level view of this. I don't want to bore everybody with all the details. So like I mentioned before, edge compute. So if you look on the right-hand side, it's evident I'm going to need compute one way or the other because I need somewhere to place my virtualized functions, right? So we take stuff off of the box that was originally on the box, and now we're going to put it on a compute platform. Not only that, we have new things that are being built through ONF, which is used to be called OnLabs. It's now the Network Function Group. They're part of the Linux Foundation. We do all our work through them. So we work with them, vendors work with them, and we developed this thing called Volta. It's virtual OLT hardware abstraction. That is it's kind of a layer that sits between the hardware box and all the stuff above it, all the PON functions above it. And so once again, I have a function now. I need to put it somewhere. So we talked about edge compute, and the reason I show edge compute is because of the future low latency services. That Volta itself, if I remove certain functions, I don't necessarily need it to be. I'm going to put this Volta, and there's a SDN controller function called, it used to be called ONUS, and now it's called V-Access Controller. So those two things are really specific to PON. And in certain configurations, I can put them back farther in the network. Like at an AIC, I don't necessarily need edge compute. But once I start looking at things like 5G backhaul and other things that are very low latency, it makes sense just to put them closer because I'm going to have to put edge compute there anyway. So you have two major functions here. You have a hardware function, you have a software function. Software is partially DNFs that are PON supported. And what I don't show here, but I do show on a later slide, is there may be other applications like virtual reality or some other things that you're going to have to place closer. Those PONs with those software functions would also sit on the edge compute. Now the hardware box here, we show white and blue. I'm sorry, we show. I don't talk about the blue, but I will. White boxes are pure SOC-based designs, i.e. Broadcom chip. Very dumbed down boxes where all the software sits there. You don't see it here, but a blue box would be, or a gray box would be it probably is going to be an FPGA based design, not SOC. It would probably be, it may have some functionality on it, but most likely still most of it's off, but it definitely is not a SOC based box. So what I show here is the optical domain for hardware. This is when I first started this conversation, I talked about kind of how we split things up. There's always going to be software-defined network function going on, and that's what I would consider in the orange and the hardware itself. But there's also this optical domain, which is going from GPON to XGS, then going from XGS to 25, 50, 100 gig. It takes a significant amount of effort within the standards to develop that next generation of technology of optics, right? Beyond whatever we do in software-defined. It's just there's always going to be hardware at the very end of this somewhere. And when I say this optical domain, that's really that hardware. It's that physical layer work that has to be done to generate the next evolution in technology so we can offer whatever, whether it's lower latency or higher speeds. And that's what's going on here, and that's what I'm trying to illustrate here. When I say edge compute above, the term right now is they used to call it mobile edge compute, MEC. They now call it multi-access edge compute. So if you're looking up terms for edge compute, you'll start seeing that floating around in the standards more, because it really isn't just to benefit mobility. It's about benefiting all types of different applications out there that may be mobile-based and may not be. like I mentioned here and I mentioned earlier, is definitely it's a unique position for us just because of the number of COs and remotes we have in our network. It's others that may be trying to enter into this market, they've got to build all of those facilities where we have a lot of this. Now, we still got to build a lot of fiber, but we have the physical plant in place in a lot of cases. So,
Ed, on that chart, could you? So what the audience is going to be familiar with is two pieces that maybe you could comment on here. One is, eComp as our management architecture plays in this, and also, more of the standards-based SDN controller, like Open Daylight stuff. How does that play into this architecture?
All right, how do I take this? So we have, it's going to depend, right? So yes, eComp is definitely target architecture. ONAP, or eComp or ONAP, whatever you want to call it.
Yep.
It's going to be, that's more of a tech dev tool now. It's more sits at the higher level, makes decisions on how to manage VNFs. It doesn't actually manage my PON systems because they're too ingrained in the tech dev systems I have today. So I still use BUMS to manage the fiber plant or to provision the equipment. I still use Granite to inventory everything, right? You can't get out of that because the Granite system is robust and designed to manage all the fiber circuits in all the plants. So we have a lot of hooks into that. What eConf will do, or ONAP will do, is they'll manage the VNFs that are created. So like I create this vAccess controller, Volta, and vAccess controller really is an SDN controller. It's just through the ONF group. And it's really considered, like it says here, it's an access controller. It's designed to manage kind of like a tier approach. You have all these access devices sitting below it. They're all being managed by it. That doesn't circumvent or remove, ODL or whatever the future may be, because, they may change their mind again. But there's still going to be connections up because I still have a fabric I've got to connect to, right? So that fabric is managed through ODL, right? The switches, the leafs, and all that stuff. So think of it as a hierarchy, right? At the end of the day, in the perfect target architecture, whenever we get there, you'll have ONAP/eConf. You'll have the larger SDN controller sitting on top of that. You have your AICs, right? And then you'll have this lower level layer of edge compute and access controller type solutions, right? That it's just tiered, right? It's just a tiered approach.
Yep.
Because even the eComp right now, the edge compute is may or may not be an AIC extension. It could be a completely different design that will work with the AIC, right? We just don't know yet, right? There's a lot of conversation going on in that space right now. But
so to net it out, you're still going to have the ability to orchestrate all the way to the edge, right?
Yes, that is the goal. Once it shows up, now depending on timing, right, this is back to if everything's not ready in eConf to do this, we may have to start with an island approach. I think everybody wants to have it managed by eConf, right? So that is the goal, but the question is timing, right? When I have time to market issues, do I go faster with something and then have to migrate later? That is not the preference. That's just sometimes the reality. So, but the target architecture, the easiest thing for everybody is target architecture is definitely ONAP eConf, sitting at the highest level, tied into all my tech dev systems today. And then below that, you'll have a kind of I don't know what you want to call it. We call it ODL, but some kind of a large-scale SDN controller. And then below that, you'll have tiered pieces. And I'm showing you the bottom piece. I'm not showing the upper pieces. I don't think I've included that in this deck. I've got other ones that talk about that. So does that answer the question? Any follow-ups on that?
Yeah, I think so. Yeah, pretty good.
Okay. So on the OCP white box, didn't talk a lot about this. This is the Open Compute Project. So when I talk about ONF, or On Labs, that's the software piece. OCP is the hardware piece. So we did this last year. We submitted designs to OCP for white box hardware designs, a 1, a 4, and a 16. A microplug is a 1. So just from an inch standpoint, just so you understand. So the microplug really is just this tiny little plug that plugs into a switch. I mean, there's thermals and everything you got to deal with, but at the end of the day, the goal was to develop, or not for us, but for a vendor to develop a design that could do this. We've tended to land it on the pizza box switch on the other side, which is either 16 or higher port count densities, mainly just because of how we deploy, and it's kind of hard for us to kind of roll a truck every time I want one PON turned up in a CO. So we tend to go in groups, larger groups, and just have it all fibered up, and that's what's led us down this path of more likely we do something with 16s or higher. This is based on an XGS PON chipset. Specifically, it's the Broadcom Maple 2. It's, like I say, a white box. So there, like I mentioned earlier, this gray and blue, it's really this idea of FPGA chipsets. And I mentioned the note below. So we've actually submitted, a couple of weeks ago, that we submitted the 24-port FPGA design. It's a footnote here. All we deploy to Dana Networks FPGA. For an OLT, this tends to allow us to move quicker. And it really doesn't affect, because we're spreading the cost out so far, it's really not a bad thing to have an FPGA OLT. It's programmable, allows you to do some stuff in the labs earlier before waiting for a tape out. So the problem with the SOC side is you got to wait for a tape out in a chip. So we've submitted a 24-port FPGA design as well. We actually have a 24-port FPGA design in our labs right now, and we're testing it. So that's probably really all I wanted to talk about was just that you'll see this, and actually I would ask folks if you want to see something in the works, go Google on a Lightspan, Nokia Lightspan. I saw a press release yesterday from Nokia that talks about some of these boxes coming out, right? So OCP is out to everybody. Anybody can build on it, and if you're a vendor and you're trying to get into our network or other people's networks, you probably want to pay attention to this. So Nokia has put out a box or a press release on a 24-port design they have. You guys can go read up on that. It's going to be actually demonstrated at Broadband World Forum in the next 2 weeks. So there are boxes out there. EdgeCore is another one. EdgeCore is a vendor that developed the OCP white box. So these are announcements. So I'm not sharing anything that's not known. And so there's two variations out in the press now and actually available. One is the white box design from EdgeCore, and then you've got the FPGA design that I know of from Nokia. So you can find press releases on that for additional information. Pretty straightforward. Ports, PON chips, and you got processing power, and then a lot of the functions have been moved off the boxes. Most vendors, I would say, have allowed themselves some flexibility because they don't want to just design a box for one use. So they usually will design the box in such a way that gives them the ability to add compute resources to if they need to place stuff on the box. So a little bit more information about open source efforts. Like I mentioned before, that I talked about Volta. I didn't talk about 1.0 versus 2.0. And as you see here, this ONUS SDN controller really is the access controller. So this is if I look at just this piece right here, I've got what I used to put in one box, we've disaggregated, right? We put functions like this Volta in place. So AT&T contributed this or started this effort because we needed a hardware abstraction layer. And that's because we really want to get to the point of open, which means any hardware vendor could come and plug into the ONUS layer above and have all the access to the PON function. So this, like I said, this is the hardware abstraction. It's like a driver, almost. And our goal is we're testing 1.0 right now in the labs. It just released a couple weeks ago from on labs. Yeah, there's definitely a press release on that as well that just came out last week. And then and we're working towards 2.0. I'm not sure yet which will be the development once we get funding and move forward. But let's just say that the design will require a hardware abstraction layer, and we're continuing to evolve it to refine the interfaces on it to include additional driver support. So basically today the drivers are embedded, so you have to compile the code with the drivers. In the future, the hope is the drivers will be separated so that anybody could just bring a driver with their hardware and they don't have to compile code every time they do it. So that is kind of a target for us. But as you can see, Volta is an important abstraction layer between the hardware and everything above it. I show here for expediency, I show ONUS going straight into OSS BSS ONAP, but there's, like I said, there's a lot of stuff above it. I'm just showing the access components themselves. Everything on the left, I'm not going to read this to you. You guys can see it as well. We've started testing in September, and our goal is to meet commitments to have a field trial going by end of year. So let's see. And I think critical. I think this is the big one. Right? We've been partnering a lot with driving a lot of our stuff through ONF. We have really tried to embrace the open source development effort methodology. So that's heavy for SDN. I think I just threw this in because it was fun. We've got drivers right now, and this is the quote I mentioned that came out from our labs president, that really latency is going to have to be something we have to consider in all networks going forward. And I'm not saying that we have a slow network today. In the PON networks, they meet the requirements that we have today. But as we start looking at 5G and virtual reality and other things, the question is going to be what's the latency going to be required for those? Because they're still not completely worked through. It depends on which model you look at. You can get a different answer. So, but I think the point is that we are definitely focused at the access side to make sure that whatever network we build in the future can support the latency requirements of whatever service needs to be put on it. That is the goal. And right now, the hardest one will be the 5G backhaul stuff. I'm sorry, not backhaul. I keep saying backhaul, but front haul, the 5G front haul applications. So this one here happens to be one of those that I have used in prior decks around virtual reality, but virtual reality is not the only thing out there that's going to be driving the boundaries as well. Now, let's jump into the future. This is stuff that that is really just standards-based at this point. You may see it drift through the halls with some executives, but it's really focusing on what is being driven, and this particularly is what's being driven out of the IEEE because they happen to be ahead of this right now for 25 gig. So I mentioned coexistence here. The point here is that to try to make sure that when I go 25 gig PON, what happens to my current network? So because of where we landed in without getting into too much detail, wavelengths, the optimal real estate in a wavelength plan is in the O-band. That's what I'm showing here, this 1260 to 1360 area. It's kind of like prime real estate. It has the least amount of issues with reflection and other reasons that everybody wants to be in the space, right? There's a whole bunch of extra space in the fiber. It's just that this happens to be the space everybody wants to be in. So, of course, we were there first with GPON. You can remember it was 1290 to 1330, and even actually before that was 100 nanometer range. So we took up most of this O-band area, and this is upstream, which means this is critical for the ONU side, right? This goes in the ONU, and it's critical to think of it this way: the wider I make this band, we're talking about burst now. Remember, burst happened from the ONU to the OLT. And how they communicate is bursts, and the lasers fire off and on. And what will happen with the laser is if when it fires off, it may drift a little bit. It may turn off, and then when it's time to fire, it heats up and it fires again. And so it has some ability to range, right, to kind of drift in between this 20 nanometers when you make it wide. The narrower this gets, think of it this way: the more expensive that optic gets, because now I've got to really tune that optic in, and I can't allow it to drift. So it requires more critical development manufacturing processes, different material usually. It usually requires cooling to keep the laser at a specific temperature so that it doesn't drift. So 20 nanometers, I love 20 nanometer because for me this is usually an uncooled laser. It's about the cheapest I can get for a design for optics. So when we started developing 25 gig, the one thing I wanted to do, my goal from a business perspective was to make sure the 25 gig could be relatively close to the same cost as XGS. Moore's Law, by the time I do 25, I should hopefully be around the same cost. So when we did XGS sits in the 1260 by 1240. We said, okay, what are we going to do to make sure I have coexistence with XGS? Well, we picked the GPON space. There was no way to make all three fit right, because I'm not showing all the wavelengths to the right. I'm just showing the clean look of XGS versus 10 gig, but there are stuff that sits in the 1330 and out. So we said, okay, we'll accept the fact that maybe there's scenarios that I want to deploy 25 gig and I don't have GPON on that circuit. Maybe these are brand new that went in with XGS, and I want to now go to 25. I could do this design. I use a coexistence element. I basically put 25 gig PONs on the XGS design. So this, like I said, this is still in standards. This hasn't been socialized much at AT&T other than within the labs groups. So that gives you an idea what one option is. This is probably, if it happens occasionally, but most of the time in standards you don't have options, at least this type of an option. This is one option. The other is this option, which is, all right, I've got GPON, and I want GPON. I didn't put XGS there, and I want to go ahead and use 25 gig PON. I can do 25 gig PON where I would have done XGS instead, and I will just, instead of 10 gig, I'll do 25. Now you see 10 gig here, but this is a different 10 gig technology than the 10 by 10. This is really like saying I could do both. I could do 10 gig and 25 gig, but not the 10 gig from XGS. It would be basically an ONU with 10 gig as a, like when you think about multi-rate receivers, it'd be a 25 and a 10. So this would be an ONT. I can do a 10 gig on the ONU, and then I could talk to the OT at 25, basically give you a 25 down and a 10 gig up, or I could do 25, 25. The point here, though, is they basically, when we designed this in the standards, we basically said, okay, give me another option. Now, what you see here is I can't support GPON, XGS, and 25 gig all in the same. There's just no way to physically make the wavelengths work. So because of that, you have an either or. You can pick this pain point, you can pick the other, but if you need both, then you're going to basically have to go to a new PON, which is kind of what we do today anyway. So this is just, when we start talking about coexistences, we're trying to design to a higher level complexity that we don't actually even support today. And that is all I had. So I will, I'll open up the questions. If there's questions you want me to answer, please.
Sure. I think you have them in a trance, Ed. The one comment you made earlier about 5G and fronthaul, I'd never heard that term before. So is that from the tower to like an in-building kind of,
Yeah, I mean, I guess if you look at, I actually may have a Vizio on that. Let me do that. Let me unshare, and then I'm going to show you a Vizio I've got on that. How do I unshare this thing? Unshare. Try to find it. I may just have to talk to it because I can't figure out how to unshare this app. Hang on a sec. I have it right here, and I just can't figure out how to share it.
Should be, if you look under your share selection, doesn't show up there as an application?
I got to find it again. Share.
Yeah, top left. Well.
Okay, can you see this share now? Can you see the Vizio?
I can see your Skype for Business contact list.
Stop. I want to share this one here. Let's see if I can share it. Okay, let me see. I want to share that too. Let me just figure out how to unshare.
Unshare. Should be a stop sharing button. If you just take your cursor and put it up at the top of the screen.
I can see share, not share. So I get these applications here. Hang on a second. Let me see if I can get this one. This is the one I want to share. This one. Okay, I found it.
There you go.
All right, so let me zoom out a little bit on this. Sorry for this. You asked. Zoom, unzoom. Let's break it out a little bit further. So I'm gonna go back to your question about 5G. So, and this is by far not complete, right? There's still so much activity in the 5G space going on, right? There's still a lot of work in standards. It hasn't been fully vetted yet. The wireless groups are working hard on this. And often they have other alternative answers, whether it's dark fiber or point-to-points they can throw at it. We're pushing on an option to use PON for supportive infrastructure in the case of 5G or other wireless technologies. Partially because as you go into these neighborhoods, you're already putting a bunch of fiber in design for PON. But here's the thing: PON's a great application for consumer because it's shared. You basically run a tree architecture. You run this thing out to a splitter. You have a single fiber strand, not even two. It's just a single PON fiber. And at the splitter, you break it out 32 or 64 ways or whatever your splitter is, and you then share time slots with every customer, right? So it works great for that design. Some work has to happen for the So I'll caveat that some work has to happen to support infrastructure just because of the latency requirements. In the specs, they call it. So today you have backhaul, right? In the future, you have backhaul and maybe something called mid-haul. You have breaks in the launch points, and it basically has certain latency requirements between those links. Because what used to happen now between the antenna and the base station now happens between this DU box distribution unit and the RU box or radio unit, right? So you have this very, very short microsecond latency requirement and that service just from this OLT port to this ONU down to this RU. So this is what causes most people the most pain if they're doing what they call an option 7. So if you look out under, this work is complex because you have the 3GPP doing work and pieces of the wireless piece, and then you've got a group called CIPRI that is really just made up of, I think today it's 4 vendors, and those vendors work up the communication protocol between what traditionally has been the BU and the BBU and the RRU. So in the future, when they disaggregate some of the stuff, they have it between the DU and the RU. And then the CU is the control unit. So the stuff here on the picture is yellow, is really all the red, is all the, what I would call 5G boxes of the future. They may be functions that are integrated, they may be together. This is just one scenario trying to show different ways we can support it through PON, assuming I get the latency figured out. So same thing here, right? I did some pictures on, CU, DUs sitting farther back. This is the hardest because now my option 7 sits back here, and depending how far this ODN is, it limits the length of my ODN, because when you're talking microseconds, you really are starting to talk about how the distance of fiber having an impact on your ability to offer that service. So it just depends, and I can't give you an actual number because they're even having debates on what the latency is between the RU and the DU. So needless to say, I don't know what this will be at the end of the day, the latency. This could be as short as 10 kilometers, which I really will fight because we design everything to 20. But more to come on that. So I'd like to talk more about this. I just, as you can see, we're starting to put stuff together for Vizio just to show this off and socialize support for infrastructure. We do this today, right? We do consumer. We do it well. We can do this all day long. Infrastructure causes some latency concerns that we've got to work through. And the nice thing is if I can make it work, it'll look something like this, is that you potentially could have, and I'm really talking more about small cells. I'm really, they have answers for macro towers. Macro towers already have a lot of fiber there. So this would be if we go into neighborhoods and we start wanting to start pushing out really high-speed wireless solutions, potentially you may be on a telephone pole, light pole, whatever, and we've already put fiber there for PON, and now I'm saying, well, can I use that fiber? And this is one example, right? I'd have multiple sectors up. I'd have multiple RUs. I'd have maybe an omnidirectional sitting on top that could be at a lower wavelength. And I potentially could have 4 multi-gig Ethernet interfaces talking to 4 different antennas, potentially. Well, I could potentially have an ONU do that and then just talk PON back to an OLT. But like I said, all this stuff is just visionary right now. We're going to have to work through this and see if we can actually do this or pull it off. So.
Yep. Okay.
Any other questions?
No, I think that's it.
Okay.
So listen, I've already got some comments about how this is really valuable information. We don't typically get to delve into this detail, into the access architecture stuff, so I appreciate you coming on and speaking to us. I know your day job is getting the technology out the door, but this is very helpful.
If you guys have more that follows up later, Bill, if there's something that comes up question-wise or you guys are thinking about it, just shoot me an email. I'm in the book.
We'll do. Yeah, we may ask you to come back next year and give us an update to see where things are at then. So
sounds good.
Okay. All right. Thanks a lot, Ed. Appreciate your time. Thanks to the audience for being on today. The recording's posted a little later on. With that, have a good rest of the day. All right. Thanks, everybody.